The Lockheed C-5 Galaxy is the largest aircraft in the U.S. Air Force and one of the largest military planes in the world. The C-5's tremendous payload capability provides the Air Mobility Command airlift in support of United States national defense. The C-5 can carry fully equipped combat-ready military units to any point in the world on short notice and then provide field support required to help sustain the fighting force. With a wingspan of 223 feet and over 36,000 cubic feet of cargo space, the C-5 Galaxy is an awe-inspiring aircraft and a crucial link in the defense of the United States of America. The craft has 12 internal fuel tanks with a capacity of 51,150 gallons, enough to fill 6.5 regular-sized railroad tank cars. So when it came time to design and build a new fuel cell maintenance hangar for the 167th Airlift Wing at Martinsburg, West Virginia, the military sought out bids from companies able to deal with the massive specifications it would take to complete the job. Kinsley Construction received the RFP.
I felt we were qualified, very qualified, and I felt like we were the choice. We do very well at scheduling, sequencing, and planning, and we do very well on a secured basis. So to me, the building was maybe secondary to meeting all those other criteria. If you have good quality control and a good team from the beginning, then you're going to find all the little nooks and crannies, the things that come to haunt you later on. You're going to find those before you get to them. So it's basically building your team and having that confidence.
Obviously, with self-performance, you do have a little more control over the project. Completing the task with your own workforce, your own equipment, and a lot of times your own methods.
We left C-5, the owner's happy. We far exceeded his expectations on that job quality-wise, safety-wise, and budget-wise.
In October 2008, Kinsley was awarded the job by the U.S. Air Force to design and build the 167th Airlift Wing's new C-5 fuel cell maintenance hangar. This was a fast-track build with a 3-month design window and a 1-year construction timetable. First order of business, the design.
The sheer magnitude of the structure itself is a bit overwhelming. The new hangar was to match an existing hangar, clear span, 75-foot hangar bay opening, supported by deep foundations.
So that gave you the basic footprint. There wasn't a whole lot of details, okay? There's a lot more research to be done.
You get the feedback from the user, and now you go seek out and find the system that best suits their needs.
You figure you can get through that on the preliminary designs, you can get through the steel structure and estimate it fairly accurately. And obviously the plan changes daily sometimes, but we knew that we were prepared for that.
Basically dug our feet in deep and took a hold of this thing. When you have the entire control of the design from day one, it certainly helps complement the construction phase of the project as well.
Once designs were approved, the build began. And that was no small order. The facility, at well over 85,000 square feet and designed to hold a plane with a maximum wartime payload capacity of 840,000 pounds, required massive foundations. Kinsley Materials provided the reinforcing bar, and Kinsley Building, in conjunction with Kinsley Heavy Highway and Bridge, poured the hangar apron and bay to military runway specifications. The hangar's door, at 250 feet wide by 75 feet high in the center section, is impressive. Even more impressive when you consider it has to open and close. Still, it's almost dwarfed by the steel structure that supports it. 2 main trusses measuring in at 25 feet high and 200 feet wide were fabricated and pre-assembled off-site. 2 200-ton cranes and 1 160-ton crane lifted the massive structures into place. Special foundations and shoring towers were designed to support the trusses until the permanent steel was erected.
Kinsley Manufacturing did a great job of taking up as least amount of space as they could from the site to build these trusses on site. It was a large building, but the site was kind of confined because we had our footprint to stay inside of. You did not cross out onto the ramp. No material crossed out, nothing crossed out without prior approval through the colonel.
So you're feet from an airfield and maybe a couple hundred feet from the C-5. We're blasting rock, and you know, any pebble goes back on that airfield and gets sucked up in a C-5 engine, we've got issues.
There's a warning right there that use of deadly force is authorized if you cross the red line for any reason.
And it was a little nerve-wracking at times. When we actually removed the shoring towers, there's a process of jacking the structure up and allowing the structure, removing the shoring towers obviously, and then allowing the structure to settle in and kind of become its own self-supporting element.
So you want to make sure that everybody knows who's got the last bolt and that everybody's tied together so when you flip the switch it all goes.
Creaks, cracks, it made a lot of noise coming down. Settled into place and it's still there today.
Working on an active military base also presented some unique challenges. With national security top of mind, no contractor was allowed to travel beyond a red line just feet off the structure without the military's approval and advanced scheduling. Crossing this line would trigger a swift and massive response from Air Force security. The facility will be used for maintenance of the 12 internal fuel tanks or cells on the C-5. That means the design had to mitigate the risk of explosion due to highly volatile jet fuel vapors. A complex system of trench drains, 500 lineal feet that are mechanically exhausted, were incorporated into the design. And with the safety of the crew and the massive cost of a replacement of an aircraft due to loss and fire in mind, the design included a high-expansion foam fire suppression system. The specifications called for 90% of the silhouette of the aircraft to be covered in 60 seconds or less. Additionally, the foam was required to cover the support area to a depth of 1 meter in 4 minutes.
So on the beginning, it seems like, oh, well, it's fairly simple. It's not a major task. What you don't realize is all the little intricacies that go into this, the location of the foam generators.
Could not fall directly on top of the aircraft, couldn't have nothing directly under the foam generators.
4, 5, 6 inches one way or another could have a direct effect on the ultimate test result.
They had, with the fire alarms and the electrical systems and the site guys had to get the water to the system.
You have to troubleshoot it as you're putting it in, not wait for the test, see where it's at.
You can plan these systems out, you can run them through computer models and different things, and on the models themselves, it said it was going to work. But always those hidden items that you just don't know how it's going to function.
In the summer of 2010, with construction nearing completion, the foam system was scheduled for testing. 16 dispersion units were suspended from the superstructure and designed to meet the military's specifications. At the conclusion of the successful test, the system was certified and the military could begin the maintenance of one of the world's largest aircraft in its new facility.
The temperature after the test went off, the temperature dropped like 30 degrees. I'm not sure if that was for the foam, it was just from the high blood pressure going down.
When we started the foam test, I'm sure everybody had a little hope that it would work, but we all knew that it would work in the end.
I think the test by far exceeded everybody's expectations.
It worked great.
The master builder concept really is an old concept where the architect, engineer, and contractor were all the same person. Kinsley Construction is really a master builder. Whenever we come on board, we try to get the whole team together and get our arms around all the disciplines so we understand the owner's issues, we understand the engineer's issues, we understand the architect's issues, and of course we understand the contractor's issues. Our job is to provide solutions. We just have to use construction to do it.